Have you ever pondered the concept of infinity? An idea so vast, it transcends our finite understanding of the world. In the realm of mathematics, infinity is not just a number, but a concept, a construct that has fascinated and perplexed thinkers for centuries. This enigmatic idea, often denoted by the symbol, is both alluring and confounding. It introduces a paradox. How can something be boundless, unending, and limitless, yet be manipulated and understood within the finite confines of human thought? It's like trying to hold the universe in the palm of your hand. Infinity challenges us to step beyond the tangible, the countable, the limited. It invites us into a realm of philosophical contemplation where we dare to question the nature of reality itself. Is the infinite merely an abstract construct, or does it have a counterpart in our physical world? Infinity, a paradoxical notion, invites us to question the boundaries of our comprehension. Infinity provokes philosophical questions about the nature of reality and the limits of human cognition. As we delve into the philosophical exploration of infinity, we find ourselves grappling with intriguing questions. Are infinite sets just mathematical abstractions, or could they have a counterpart in the physical world? Consider this. We know that the set of all natural numbers is infinite. But does this infinite set have a tangible equivalent in reality? Can we point to an actual physical entity that embodies this endless collection? This question treads the fine line between abstract mathematical concepts and the tangible physical world we perceive. The philosophical discourse around infinity doesn't stop there. It also brings to the forefront the tension between the abstract and the tangible. On one hand, infinity is an abstract mathematical concept, a tool we use to make sense of the boundless and the limitless. On the other hand, the tangible implications of infinity are far-reaching, affecting everything from our understanding of the universe to the practical applications in physics and engineering. This tension between the abstract and the tangible is what makes infinity such a fascinating philosophical subject. It forces us to question our own understanding and perception of reality. How do we reconcile the finite world we live in with the concept of the infinite? How do we make sense of something that is inherently boundless within the finite confines of our cognition? The philosophical exploration of infinity also prompts us to reflect on the limits of human knowledge. If something as fundamental as a number can be infinite, what does that say about the potential for human understanding? Are there limits to what we can know, or is our capacity for knowledge, like infinity itself, boundless? Infinity propels us to contemplate the very fabric of existence and the boundaries of human knowledge. As we grapple with these questions, we find ourselves on a philosophical journey that transcends the finite world. Infinity, in its paradoxes and complexities, serves as a catalyst for this journey, challenging us to look beyond the boundaries of our own understanding and perception of reality. In the late 19th century, mathematician Georg Cantor introduced a revolutionary concept: transfinite numbers. Cantor, a trailblazer in the realm of mathematical infinity, dared to venture into the unexplored territories of the infinite. His journey led him to an astonishing revelation, a concept that would forever alter our understanding of infinity: the concept of transfinite numbers. Cantor's work was groundbreaking. He proposed that infinity wasn't a singular, indivisible entity. Instead, he suggested that there were different kinds and sizes of infinity, each more expansive than the last. This was a radical departure from the traditional view of infinity as a boundless, unified concept. Cantor was proposing a universe of infinities, a hierarchy of boundless sets, each dwarfing the one before it. This concept, known as transfinite numbers, was both intriguing and perplexing. It challenged our intuitive understanding of infinity, forcing us to reassess our perceptions. If there were indeed different sizes of infinity, what did this mean for our understanding of the infinite? How could one infinity be larger than another? These were the questions that Cantor's transfinite numbers posed, questions that stretched the boundaries of our mathematical comprehension. Cantor's revolutionary concept was not without its critics. Many mathematicians and philosophers were skeptical of his ideas, dismissing them as abstract and impractical. Yet, despite the controversy, Cantor's concept of transfinite numbers has endured, becoming a cornerstone of modern set theory and a critical tool in the exploration of the infinite. The philosophical implications of Cantor's work are profound. His concept of transfinite numbers challenges us to rethink our understanding of mathematical reality. It prompts us to question the limitations of our intuition, urging us to embrace the paradoxical nature of the infinite. Cantor's work is a testament to the power of mathematical inquiry, demonstrating how it can push the boundaries of our cognition and lead us into uncharted philosophical terrain. Cantor's concept of transfinite numbers prompted us to question the nature of mathematical reality and the limitations of human intuition. His groundbreaking work continues to inspire us, beckoning us to venture deeper into the infinite, to explore the paradoxes and complexities of the boundless universe of mathematics. Opening, mathematics with its infinite sets, series, and limits serves as a powerful tool for exploring the nature of infinity. The dance of numbers and symbols in mathematics provides us with a vessel to voyage into the vast sea of infinity. It's a journey into the limitless, where the boundaries of human comprehension are constantly challenged and expanded. Mathematics allows us to grapple with the unbounded. Through the concept of infinite sets, we delve into an endless collection of elements, each one distinct, yet part of the whole. It's like staring into a mirror placed opposite another, creating an infinite series of reflections. Each mirror image is a representation of the same object, yet each is distinct, a part of the infinite continuum. Similarly, mathematical series with their unending sequences of numbers guide us through the winding path of infinity. They demonstrate how a simple progression can extend beyond the horizon of our understanding, leading us into the realm of the limitless. It's like gazing at the night sky, where each star is a point in an infinite series, each one distinct, yet part of the grand cosmic tapestry. Then, there are limits, the mathematical concept that encapsulates the essence of the boundless. Limits push us to the edge of the finite, permitting us to peek into the infinite. They are like the edge of a cliff overlooking the sea, where the ocean seems to extend into eternity, yet its vastness can be captured within our field of view. In grappling with these concepts, we push the boundaries of mathematical inquiry. Mathematics transcends its traditional confines and ventures into the philosophical. It becomes an intellectual playground where we can wrestle with profound questions about the nature of infinity and the limits of human cognition. In this exploration, we encounter the paradoxes and complexities that infinity presents. Yet they are not roadblocks, but signposts pointing us towards deeper understanding. They challenge us, provoke us, and inspire us to continue our exploration, to delve deeper into the mysteries of the infinite. Closing. Mathematics becomes a philosophical endeavor, providing a framework for contemplating the infinite and transcending the constraints of the finite mind. Infinity, in its complexities, becomes a gateway to philosophical reflection. As we have journeyed through this enigma, we've grappled with paradoxes, contemplated philosophical questions, and examined the revolutionary concept of transfinite numbers. Infinity, in its most basic form, presents a paradox. Its boundless nature is at odds with our finite human comprehension, yet we have found ways to manipulate and understand it within the confines of mathematics. This paradox, while challenging, has spurred mathematicians and philosophers alike to delve deeper, to question, and to explore. The philosophical implications of infinity are broad and profound. It prompts us to question the very nature of reality. Are infinite sets simply mathematical abstractions, or do they have tangible counterparts in the physical world? This tension between the abstract and the concrete, the theoretical and the empirical, invites us to reflect on the fabric of existence and the boundaries of human knowledge. The concept of transfinite numbers, introduced by Georg Cantor, revolutionized our understanding of infinity. No longer was infinity seen as a singular, indivisible concept, but instead as a continuum of infinities, each more expansive than the last. This revelation sparked debates about the nature of mathematical reality and the limitations of human intuition, further deepening the philosophical dimensions of infinity. Mathematics, with its infinite sets, series, and limits, serves not just as a tool for computation, but as a vehicle for exploration. It allows us to grapple with the unbounded and the limitless, to push the boundaries of inquiry, and to transcend the constraints of the finite mind. In essence, infinity is more than a mathematical concept. It is a philosophical journey, a profound exploration of the nature of existence. As we navigate the intricacies of infinite sets and transfinite numbers, we find ourselves on a journey that transcends the finite world, challenging us to contemplate the infinite not just as a mathematical concept, but as a profound exploration of the nature of existence itself.